Welcome to ABB Switzerland. We are here in the excitation system R&D, and my name is Henry Nikolaus. I'm leading the hardware and systems development team. An excitation system is important for synchronous machines like generators and motors. They provide the field current to the rotor winding, which is important for the magnetic field. We develop excitation systems for a wide range of power plants, like our smallest product, which is used in small hydropower plants, until the biggest units in the world, which are used in nuclear power plants. I think it's pretty important for the energy transition nowadays. We make sure that the power plants are on the grid, that they are stable, and that they're producing the right power when it's required. Today, I'm going to show you how we test hardware and software for excitation systems. Excitation systems you can find in all power plants, so everywhere where a synchronous machine is working, an excitation system is inside. We regulate the voltage of the generators and make sure that we adapt to changes and keep the grid stable. Now we have arrived in our laboratory and my colleague Thomas will show what we do here.
We can simulate here minus 40 to 85 degrees. That's the range of our electronics. To have some margin also. We go sometimes deeper and higher. We are simulating here the temperature and also humidity for extreme environments. For example, here minus 40 degrees, that's more like for transportation, but also minus 25 is could be by commissioning when the power plant doesn't have a heating, and also up to 85 degrees, that's for the electronics, because the temperature around the device can be also 60-70 degrees. Now I'm taking the device on the vibration table to have it tested up to 5 Gs. With up to 2000 Hertz. We have to secure it here, like our customers will do in the power plant. So it's the same as installed in the power plant. So every axis is tested, and we test it for resonances, mechanical resonances, and if it survives or if any parts get loose. We test it because sometimes these devices will be mounted in the near area of the big machines, and the machines always vibrate, and also if you have a floor, then you also have little vibrations, and these can be bigger or slower vibrations. And also we test it for transport. Doing transport it's packed, of course, but there are also some standards that require that we test it under transport condition.
Welcome to our low voltage lab, where our hill is located, and my colleague Ralf will explain what it's exactly doing.
We develop control software for excitation systems, and we rely on a software-in-the-loop technique, which means we are able to test parts of the control software extensively and gradually integrate new functionalities to the control software until we reach a level of development and confidence in the control software such that we can start testing it in a real hardware. When we reach this point, we start testing it in our very nice test setup that we have here, and I would like to show how it looks like. So in this test setup, the main components are our own controllers, of course, and also a so-called hardware-in-the-loop system. This system is capable of simulating a complete power plant with a generator, transformer, etc. Let's say, for example, a power plant, and feeds the measurements to our controllers. It also emulates the converters of the excitation system, so that the controllers we have will really give the control signals to these emulated converters, and we can test this interface very thoroughly as well. The hardware-in-the-loop tests allow us to run test cases that would be probably unsafe for people or for the equipment, and we can run them and repeat them as many times as we like to evaluate how the system would behave in these extreme scenarios. Another advantage of these hill tests that we run is that they are fully automated, which means we can also use them as very efficient regression tests also for software releases in the future. So this is an example of a test we would run on the hardware-in-the-loop setup. In this case, we are focusing on the converter measurements and checking that its operation is as expected. We can also check specific and special operating cases, such as breakdown of a component or asymmetrical operation of the converter and things like that.
Now, after a lot of testing inside the laboratory, we have arrived in the factory with our board, which can now be assembled to a real customer project, which is used in a small hydro power plant. Thank you very much to following excitation inside. And next time when you switch on the light, then think of an excitation system.